Alright guys, we're back with the isotopes video. I didn't want to make the video too terribly long for ions, so went ahead and kind of cut these in half and split them, which is fine. Isotopes, just like they are with ions, we're going to talk about having the same number of protons. This time we're going to change and have different number of neutrons. Why that is important is because these two, protons and neutrons, are going to impact our atomic mass. So the mass of these atoms are going to change. The charges of the atoms are going to stay the same because our protons and electrons are going to equal each other out still. But the mass now is going to change. And remember, an isotope is just a naturally occurring different version of an atom that already exists. So we'll start with the famous one that we have. We have carbon 12, but also we can have what is called carbon 14. Carbon 14 is the one that they use in the dating of the animals and organisms as they pass away. Again, really the only difference is the atomic mass here between carbon 12 and carbon 14. So if we take a look here, both of them have an atomic number of 6, which tells us that both of them have 6 protons, which also tells us that that is the carbon atom that we're using. If the atomic number changes, we change the element that we're actually talking about. For this specific one, the atomic mass is equal to 12. And remember, we know the atomic mass is equal to protons plus neutrons. So if the atomic mass is 12, we know that both of these guys have 6 protons in it. Now all we need to do is solve for the number of neutrons. And you guys know how to do that. Simple math. And then if you get over here, you should have 6 neutrons. Nothing special about it. Again, just identifying how many protons, neutrons, and electrons are inside of these atoms. For this guy over here, the atomic mass is equal to 14. Now, if you look on the periodic table, you'll notice that the atomic mass of carbon is really 12.01. How can it have 14 for this? The mass is for the specific atom that has that amount of protons and neutrons in it. So for carbon 14, it is going to have, again, atomic mass is equal to protons plus neutrons. We know we have an atomic mass of 14. We know we have 6 protons. So now we just need to solve for the number of neutrons. And if we do our math correctly, we should find out that we have a total of 8 neutrons in this atom for carbon 14. Again, isotopes are nothing more than elements that have the same number of protons, different number of neutrons. One of the ways that you will see kind of how we write these out is for carbon 12. A lot of times you will see a C-12 letting you know that it is carbon 12. For carbon 14, a lot of times you'll see a C-14 where the carbon implies the 6 protons already in there, or the atomic number, and then the dash is the atomic mass that's associated with it. Again, just a quick review of how we figure out ions and isotopes and how we can figure out the number of protons, neutrons, and electrons inside of there. Since we have an atomic number of 6, and the atom is going to be neutral because we're not talking about changing the charges in isotopes, it would have 6 protons and 6 electrons, and the number of neutrons would vary based on the atomic mass. So for carbon 12, it would be 6 protons, 6 electrons, 6 neutrons. For carbon 14, it would be 6 protons, 6 electrons, and then 8 neutrons from there. And you can do that with any of our elements that are up there. Again, just taking a look at the number of protons, neutrons, and electrons.